Satellite estimated sea surface wind shows gale warning area in leeward side of A23. It was very interesting to find a high wind speed area just around A23a. I have analyzed the sea surface wind data, which is available from NOAA National Centers for Environmental Information blended Seawinds by the near real-time or as archive data. The wind speed vectors are colored by a discrete color ramp, from black, skylight, yellow, red and violet with a background color of dark blue. This color ramp is designed to identify the wind speed at 5, 10, 15, and 20 meters per second. Although it is not a linear or continuous color coding, it is easy to read an order of wind speed from the color on vectors. 20 meters per second means a high wind speed more than 20 meters per second. This is a plot of wind speed on March 4th around A23a. A23a was grounded on February 25th with a slight drifting to the southeast, but it is not drifting at all on March 22nd. The wind speed in the windward side, the upwind side, of A23a shows 10 to 20 meters per second. The wind speed in the leeward side, the downwind side, of A23a shows about 90 meters per second. The wind's running distance in the leeward side was about 50 kilometers. This wind's running distance is not enough to make it swell. The sea state under these high surface winds could be severe and a gale warning could be declared, but this phenomenon is not so big or this area is not frequently accessed by the people. Next view graph shows a conceptual diagram of sea surface wind around A23a on March 4th. The wind speed in the windward side of A23a was around 10 meters per second. The wind over A23a carries a huge amount of air mass and A23a will cool down the air mass and make it dense and heavy. It takes about 3 hours to cross A23a with a wind speed of 10 meters per second. Repeatedly, the air mass over A23a will be cooled. Finally, the strong wind will blow down like a downburst on the leeward side of A23. Although there is not any observation of sea states, it is expected the sea state is very high. Also, the upwelling could be expected on the A23a leeward side. Almost all of the wind vectors exhibited an array of one direction without any cyclonic or anticyclonic vectors. This suggests the strong wind could have occurred very close to A23a. This is a view graph of a false color image observed on March 4th by the visible infrared imaging radiometer suites on NOAA 21 and surface wind vectors as well as previous view graph. Snow, sea ices on the surface and snow particles in the clouds are colored yellow and water particles in the clouds are colored white with a band combination of the visible infrared imaging radiometer suites. There are not any clouds around A23a and there are not any downwelling cold sources, which may grow up to the downburst. This condition strongly supports the downburst associated with cooling capability of A23a. As we can observe, the downburst area is limited to 50 kilometers and more on the leeward side of A23a. It is a very small phenomenon. But the cruising vessels should be careful of the downburst in the leeward side of A23a. This is a view graph of a sea surface temperature distribution observed on March 4th by the visible infrared imaging radiometer suites on NOAA 21 and surface wind vectors as well as previous view graph. The sea surface temperature is observed by the thermal infrared bands of visible infrared imaging radiometer suites. The sea surface temperature is colored from dark blue to dark red corresponding to the range from -2 to 10 degrees Celsius. It is possible to observe slightly colder water in the leeward side of A23a. This suggests the upwelling of nutrients-rich water mass from the deeper layer. As the water in the leeward side of A23a is around 5 degrees Celsius and the temperature difference between upwelled colder water and surrounding water is not so big, I would like to have a chance to explain the circulation mechanism around South Georgia Island in the near future. This is a view graph of chlorophyll A concentration observed on March 4th by the visible infrared imaging radiometer suites on NOAA 21 and surface wind vectors as well as previous view graph. The chlorophyll A concentration is estimated through a bio-optical algorithm combining multiple bands of visible infrared imaging radiometer suites. The chlorophyll A concentration is a proxy of phytoplankton in the water, as the chlorophyll A is the pigment of photosynthesis in the phytoplankton. In this view graph, the chlorophyll A concentration is colored from dark blue to dark red, corresponding to the range from 0.01 to 20 mg per cubic meters. The gray-colored region is the area where clouds are presented and the bio-optical algorithm did not work. The slant lines in the gray are the banding noise of visible infrared imaging radiometer suites, and are not representing the chlorophyll A concentration. When we pay attention to the leeward side of A23a, the water mass close to A23a is indicated as the water with a higher chlorophyll A concentration. In contrast, the water mass under the high sea state area with the downburst is indicated with a lower chlorophyll A concentration. There is a strong vertical mixing under the strong surface wind, and there is no chance to increase phytoplankton. There is a high chlorophyll A concentration in the northwest offshore or Georgia Basin, and I would like to have a chance to discuss in the near future. On March 8, the surface wind exhibited a cyclonic pattern, clockwise circulation in the southern sphere. A lower pressure system leads to rising air and is causing cloud formation and precipitation. Although the enforced surface wind over A23a is dense and heavy, the air mass was raised with cyclonic winds. The satellite estimated surface wind was 30 meters per second on March 8. It was difficult to observe the sea surface temperature or the chlorophyll A concentration because of clouds. On March 12 and 13, 2025, the westerly wind was dominant to A23a and South Georgia Island. A23a contributed to enforcing the sea surface wind, and the wind speed on the leeward side was 25 meters per second on March 13. Although the wind ceased to 15 meters per second at the west coast of South Georgia, the west coast experienced the strong winds and waves. The penguins or seals on the west coast might fight over the bait more than usual for these 2 days. The approach of A23a and westerly wind exhibit the negative impact for penguins and seals on the west coast of South Georgia Island. In this case, cruising vessels passing through between A23a and South Georgia Island should avoid this route because of the enforced winds by A23a. I would like to keep watching A23a, and I am interested in the contribution of A23a to the primary productivity around South Georgia Island. I am looking forward to hearing your comments on this report.